All right, so now we'll go on to the second one. So the second one says for the circuit starting in state Q4, Q3, Q21, Q2, Q1, Q0 equals 1, 0, 0, 1, 1, show the next three states from that starting point where purple equals 0, 0, 1 over 3 consecutive clock cycles. So what you do is you make yourself a little chart, Q4, Q3, Q2, Q1, Q0, and does that blue show up? Yeah. And also our variable purple, and it starts with 0, and it starts with 1, 0, 0, 1, 1. Okay, so now on the next clock cycle, I was explaining to some people before we started. Oh, I bet it doesn't pick up my voice when I walk over here. I was explaining to some people when we started that you want to be careful about whether you're looking at the current state or the state from the clock cycle before, because remember, it acts on the positive clock edge right when the clock turns. So right when the clock turns, whatever is sitting there at that D input is what it's going to take. It's not going to wait for the flip-flop before it to finish doing what it's doing and then take that new one. So it's going to look at what it had from the time before. So when we start right here, Q4, let's see what Q4 has. Q4, so that's 0, and then our next purple value is 0. So purple is 0, so that means that we're going to take what's going into the 0 part of the flip-flop. And for Q4, that, as I'm tracing it, so I'm tracing it right there, is Q1. And so I want to look and see what was Q1 on the clock cycle before, and it was 1. Okay, now Q3, again purple is 0, so we're looking at what's going into the 0 input, and we'll trace here, and we'll trace, and we see that was Q0. So what was Q0 on the clock cycle before? It was 1. Now Q2, what's going into the 0 for Q2? It looks like it's Q4, and Q4 for the clock cycle before was 1. Q1 is getting Q3, and the clock cycle before Q3 was 0. And Q0 is getting Q2, and Q2 was 0. Okay, so now on our next cycle, purple becomes 1. But we're still going to be using, let me make sure I got this right. Right. Okay, so purple has changed, but we're still acting on the edge of the clock cycle. So we're still acting right with what's right here sitting ready to go at the D input. And so we're still using what's coming into the 0. Yes?
Wouldn't we do another purple is 0, because it starts at 1, 0, 0, 1, 1, but then it starts the instances where purple is 0, 0, 1.
Well, I'm actually doing 0 right now. It's kind of a how you notate it. So yes, I'm doing 0. Even though I wrote a 1, I'm doing 0. And that's what I was just saying, because even though it's purple is changed to 1, it's still acting as if it's 0 because it's still, that's what's there sitting on the clock. So I used to write it, okay, so I used to write it like this. I don't know which is right. Okay, so I used to write it like that. And the way he writes it is like this, but then we have an extra row here to take into account that last 1.
Right. Okay, so you basically just define where you started. Okay.
Okay, so we're still going to be using what's going into the zeros. So for Q4, we determined that what was going into the 0 was Q1, which is 0. And for Q3, what was going into the 0 was Q0, which is 0. For Q2, what's going into the 0 is Q4, which is 1. For Q1, what's going into the 0, I can't tell anymore. I think it's Q3, which was 0. And Q0, what's going into the 0 is Q2, which was 1. And I messed up. Q1 is wrong. Let's see. So Q1, what's going into the 0 is Q3, which was 1. Okay, now we have our last set here, and our last set goes along with purple being 1. And so now when purple is 1, we're going to be looking at what goes into the 1 terminal of each of these. So for Q4, what's going into the 1 terminal was Q0, which is 1. For Q3, what's going into the 1 terminal is Q4, which is 0. For Q2, what's going into the 1 terminal is Q3, which is 0. For Q1, what's going into the 1 terminal is Q2, which was 1. And for Q0, what's going into the 1 terminal is Q1, which is 1. Okay, so questions here before I stop to save the recording?